In this tutorial, we're going to see how to build a URL shortener application using the Go programming language and Couchbase. So what we're going to do is, the whole point of URL shorteners is you're going to provide it a long URL, generally something that you can't remember, something that's hard to distribute through a text message, and we're going to use a hashing function to hash it, make it shorter, and then allow users to pass that around and still navigate to the correct destination URL. Again, we're going to be using Golang, so the Go programming language, as well as Couchbase as our NoSQL database for storing these short URLs. So we're going to start from scratch here. We're going to start with a fresh Go project. We're going to start by setting up a Couchbase bucket. The requirement here is that you already have Go installed on your computer, and you also have Couchbase installed on your computer. So we'll be using Couchbase 4.1 or higher for this example, because we will be using what's called the Nickel query language, which allows you to run SQL queries against your NoSQL JSON data. So before I go ahead and start my actual project, what I do want to start is I want to start by setting up my Couchbase bucket. So if I go to my web browser, I am already connected to a Couchbase instance. It is not on my local machine. It's actually on another computer I have lying around, but I am connected to it. It's on whatever my host name is, and then port 8091. So while I'm navigated to it, I logged in. It's installed already. And if I go to my data buckets, I have one data bucket called default, but we're not actually going to be using this particular data bucket. You could, but we're not in this example. So what we're going to do is we're going to create a new data bucket. We're going to call this data bucket example, and we're going to leave it as a Couchbase bucket type. This is going to just be a very small example, so I'm going to lower the memory settings. That really doesn't need to be that high. Even 256 megabytes is way too high for this example. And then I'm going to leave everything as is and choose create. So it is creating it right now. It's in the process. It's still yellow. Now it's done. But the thing about this is we're going to be using Nickel queries. Nickel queries require indexes to be created, at least one index. The more indexes and the more precise indexes that you have, the higher the performance your queries will be. But again, this is just a small application, so we're just going to create one very basic index. So if you're using the Enterprise Edition like I am, what we're going to be doing is we're going to be using Query Workbench. It comes with Enterprise Edition. If you're using the Community Edition, that's fine. You can use the Couchbase command line tool, so the shell tool called CBQ. There is documentation online on how to use that tool if that's your scenario. But what we're going to do is we're going to say create primary index on, and then we're calling it example. That's the name of our bucket. And then we're going to use the global secondary index and choose execute. So it did create that index for us. And if we go to the indexes section, I can look at example, and it does in fact have that primary index. And like I said, it's best if you create specific indexes towards your queries. It'll be faster, definitely better for production. But this is just a basic example, and this will get us by perfectly fine. So we do have Couchbase configured at this point. Now we can focus on our Golang application. So if I go back to my screen with the terminal open, what I want to do is I want to navigate to my Go path. So I can say cd go path, and then in my case, my Go path is source github.com/nraboy. So Go path is the path that you set up when you install Golang. If you haven't already done that, I do recommend that you configure Go properly before proceeding with this tutorial. So I'm in that directory. I'm going to create a new directory. I'm going to call it short URL, and I'm going to navigate into it. And now I'm going to create a file called main.go. So I'm going to say touch main.go. And I'm doing a lot of terminal work here. If you'd prefer to create these directories and files manually using Finder or Explorer or whatever you're using, that's fine too. I just prefer the terminal. So whatever works for you. So I'm going to clear this. I'm going to figure out what my path is. You can see it's this is my path to my Golang Go path, as well as source GitHub and nraboy, and then short URL. So I'm going to open this project in an editor of choice. You can use whatever editor you want. I'm going to be using Atom by GitHub. So I'm going to say Atom dot, and that'll open up my project. And I have main.go available to me, which is empty. Going forward, I do have certain plugins installed in my Atom editor that will enable certain auto completion features. So for example, if I try to use different packages, it will automatically import them for me. If your editor does not do that for you, that's fine. I'm going to go ahead and elaborate on what exactly was added by my editor. So you shouldn't feel like you are left out because you're missing the features that I have. Don't worry, I will go through everything and we'll make sure that this URL shortener application is a success. So what we're going to do is we're going to say whoops, I'm not actually in my editor here. I'm going to say package main, and I'm going to declare a main function. So I'm going to say function main, and actually let me zoom in on my font. That should be large enough. I'll zoom in further through post-processing as well. But function main, and what we want to do is, well, we're going to be creating a RESTful API here. To make that easier on us, we're going to install a dependency. So my editor doesn't install dependencies for me. I do need a terminal for that. The dependency for making this RESTful API easy for us is we're going to install a tool called Mux. It's an application routing tool that allows us to create routes easily. So when I say routes, I mean endpoints. So what we can do is we can say go get github.com/gorilla/mux, and Go will go ahead and install that for you. So let's go ahead and continue adding our code now that it's installed in our project. So what we can say is we can say router equals mux, and we can say dot new router and close that off. And if I hit save, it should import it now into my project. Yeah, so it did add that import, and that's again a feature of my editor, and it's probably yelling at me here because I'm not actually using router. It's declared but not used, which is fine. Let's proceed down the line here. We will be using Couchbase in our project. So what we want to do is we want to go back into our terminal, and we want to say go, and then we're going to say github.com/couchbase/gocb. And now that's installed. So going back into our editor here, I'm not going to actually use Couchbase yet. I'm going to go down the line here. Instead, what I'm going to do is I'm going to declare my routing endpoint functions. So let's go ahead and do the following. So we're going to say router dot handle function, and we're going to add our first path is going to be create. So this is going to be the endpoint that is hit when we wish to take a long URL and turn it into a short URL. We're going to pass in a function. We haven't created this function yet, this method, but we're going to say create endpoint, and we're going to create that next. I'm going to say methods, and this is going to be of type put. So this is a creation endpoint. The next thing that we're going to do is we're going to say add another one. This endpoint is going to be called expand. And this time, this is going to be a GET request. So I do have an extra slash at the end here. If you don't, it might error out for you. But this endpoint is going to call the method expand endpoint and methods get. And then finally, we have router.handle function, and we're going to say slash, and then in brackets, we're going to say ID. And I'll explain why we're doing that in a second. But this is going to be called the root endpoint. And I'm just making up names here as far as these endpoint methods. But this is going to say methods get. So the point here is, so for ID for this root path endpoint, we're going to be hosting the API and our, like, we can call it tinyURL or URL shortener project on the same host, on the same port as well. So while we can hit the endpoint /create to create these short URLs, these URLs are going to have a hash created for them. So if we just append that hash to the root path, Well, in theory, what we would want to do is we would want to just navigate at that point. And this will be more clear as we go along. But our root endpoint will just be our redirection endpoint. Expand will take a short URL and turn it into a long URL. So it'll get whatever the long URL is. And then, of course, again, we'll create a short URL from the long URL. All right, so we do have each of those endpoint methods. We have the names declared. So what we want to do is we want to actually create those methods now. So we can say function. Let's say expand endpoint. I'm not going in any particular order here, but we're going to say W. So for our writer, we're going to say HTTP dot response writer, and then request, and we're going to say HTTP dot request. And if I save it, HTTP should be imported automatically. And of course it was. So I'm going to go ahead and go down the line here. I'm going to copy this. So I copied it 3 times. I'll rename it because essentially these are all going to be formatted the same from the start. So this one will be called the create endpoint, and this one will be called the root endpoint. And I'll hit save. So the errors went away down in my main function. And then finally what we want to do as far as our bootstrapping process here is we want to say log.fatal. So if there's some kind of error when we're trying to start the server, we'll print it out to our logs. We're going to say http.listen and serve. And then we're going to listen and serve on port 1, 2, 3, 4, 5. Keep it simple here. And then we're going to pass in that router that we created, and we can hit save. So at this point, we don't really have much. It's just really the foundation here. It likely won't even run if I try to run it because these endpoints, they don't print any information. They don't do anything really. But we can go ahead and build it anyway. So we're going to say go build, and what it did was it created a short URL executable file. And if we wanted to, we could run it and it should serve on that port. But again, it won't do anything at this point. So now that we have kind of the foundation laid here, what we want to do is now let's create our database model. Because Golang, we do want to create a database model before we start working with data. So whatever we're going to be storing in Couchbase server. So let's create a struct for that. So we're going to say type my URL struct. And we're going to give it an ID. It's going to be of type string. And we're also going to provide a JSON mapping. So we're going to say JSON ID, and then we're going to omit it if it's empty. And the reason why we're providing this JSON mapping is because we want to know how it's going to look inside of Couchbase server. The properties that we define in the struct are used in Golang, and then the properties we define as far as the JSON mapping is what we see in the database. So let's go ahead and define long URL. And the mapping for that, let's give it a long URL with a lowercase l. And then finally, short URL string. And the same thing applies. And we can save it. All right, so we do have our model. We don't have any connection established to Couchbase yet. What we do want to do is we want to establish a global variable. So that way we can access that connection throughout our application. So what we're going to say is we're going to say var bucket gocb.bucket. And that's going to be so this bucket variable, we're going to be able to use it to query our database from any one of our functions. We also want to keep a global variable to our application for the bucket name because that'll be useful when it comes to querying. So we're going to call it bucket name, and that'll be of type string. So inside of the main function, let's go ahead and establish that connection. So underneath the router, where we create the new router, let's go ahead and do the following. Let's say cluster, and then we won't record an error, but we're going to say gocb.connect, and we're going to say Couchbase, and then we're going to provide it a host name. So I don't remember my host name, so I'm going back to my web browser here. It's 10.0.1.62. I'm going to copy that. I do not need the port or the trailing slash, or it seems to have pasted an extra HTTP in there. I just need that host name or IP for one node in my cluster because the cluster itself is peer-to-peer. So the next thing that we can do is we can define our bucket name. So we're going to say bucket name equals, we called it example. And then let's go ahead and try to open up that bucket. So we're going to say bucket. Oh, we're not going to record the error again. And we're going to say cluster.openBucket. We're going to say bucket name. And our bucket, in this case, does not have a password. And we can save it. So at this point, we can actually query Couchbase. We have an open connection. We have an open bucket. We are, at this point, ready to go. So we're going to start things off with the create endpoint right here. This will probably be the most complicated endpoint of the three, which is fine. It's really not too bad. The logic behind this is what we're going to do is we're going to first check to make sure that the long URL doesn't already exist in the database, because we want only one long URL and one short URL combination. If it exists, we're going to return whatever is in the database. If it does not exist, we're going to create a new short URL, long URL hash combination, and then return that. So we will be using another package. So this is the third package we've installed. So far we've installed GoCB for Couchbase. We've installed Mux. What we do want to install now is we want to install a package called Hashids. So what we can do is we can say the following. Go get github.com/speps/go hash IDs and hit enter. So it'll download that hash IDs package, and this will allow us to convert numeric values into short hash values. I'm not saying MD5 hashes or SHA hashes because those are very long. These are short hashes, like 5 characters long, something that you would expect in the URL shortener. And this saves us the trouble of having to create our own hashing algorithm as well. So that package is included. So now let's worry about that create endpoint. What we want to do is we want to say var URL, and that's of type my URL. We want to decode the post body. So create endpoint, this is a put request. It has a request body. It's going to be JSON format. We want to decode that body and store it so that way we can use it. So what we're saying is we don't need to record any kind of error, but we're going to say JSON.new decoder and then request.body.decode, and we're going to store that inside of URL. Now we're going to define our query parameters object here. So we're going to say var n1 ql params, and this is going to be an array of interface or a slice of interface. Now let's go ahead and add our long URL to the list of parameters. So we're going to say n1 ql params equals append n1 ql params url.long URL, because that's what we defined in our structure, and that's what we're expecting to come in. So we're expecting a value called long URL, a JSON value, and then we can access it with long URL with a capital L. Now that we have our parameters defined, because this is going to be a parameterized query, we can actually execute that query. So we can say query equals GoCB.new nickel query, and let's provide it a statement. So we're going to say select. We're going to use the backtick, and we're going to define bucket name, so our variable that we defined inside of our main function, dot star, so we're selecting all properties for this particular bucket. All properties should only be the ID, long URL, and short URL, but we'll get to that in a minute. From, and we're going to say backtick again. I do backticks, although in this scenario we don't actually need them, Backticks you need if your bucket name has a hyphen in them. Our particular bucket example does not have a hyphen, but I like to use it as good habit to include them anyways. So I'm going to say bucket name plus where long URL equals $1. So $1 being our parameter that is user generated. So it was passed in with our request body and added to this slice of interface. So I have my query. Now let's actually execute that query. So we're going to say rows. So this is our result, or we're going to collect an error if an error exists, equals bucket dot execute nickel query, and then our parameters are actually going to be n1 ql params because that's what we've named them as. So we've executed it. Now what we want to do is we want to see if there's any kind of error. Maybe our bucket name was incorrect. Maybe there's some other problem. Let's go ahead and say if error not equal to nil. So if there was an error, what we want to do is we want to respond with that error. So we're going to say w.write header 401. We're going to say w.write, and this is going to be a slice of byte error. So after we do this, we need to return. So the reason why we're returning is because after we've written to the screen here, outside of this if statement, we're going to be trying to write again. So if we hit an error and we write and then we try to write a second time, our Go application is probably going to blow up. So that's why we're returning. We don't want to write again after we have written already. So we write this error to the screen as a response. If there was no error, what we can do is we can say var row my URL. So we're creating another variable here. We can say rows dot one. So we're getting the first result because there should only ever be one result. Ampersand. And we're going to say row. And we need to see if that row actually contains data, because even if the query succeeds, it doesn't mean that we're getting anything in the results. So we need to say if row equals, I'm going to say my URL. So we need to see if it equals a new struct here. That means that it's undefined. Well, it's not undefined. It's just there's no data in it. If row equals a new struct, what we're going to say is that, well, it doesn't exist. So we need to create it. So we can start using that hash IDs function. So we're going to say HD, we're going to just define a variable here, equals hash IDs dot new data. And then we need to create a new hash ID or a new hash based on that new data. So we can say H equals hash IDs dot new with data HD. Now we need to get the timestamp, because remember, we're going to be hashing a numeric value, and we want to make sure that it's unique. So if I try to hash the value 1, I'm going to get the same value every time. That's not what we want. So what we're going to do is we're going to hash the timestamp, so the epoch time, the time in milliseconds, and we are going to use that as our unique value. So what we're going to say is we're going to say now equals time.now, and we're going to say URL. Remember the URL that we defined up on line 25, short URL equals, you know what, I'm not there yet. Let's say ID. We're going to find the ID first. So we're going to say we're not going to worry about an error here, equals h dot encode. So this actually takes in a slice of integers. So we do need to do some conversions here. But we're going to say int now.unix, and we're going to store that value. So this is going to be our hash. We're going to store it as an ID. It's a string now. And now we can actually store that as the short URL. So I skipped a step here, but we're going to say URL.short URL equals HTTP localhost 12345 / plus URL.id. So why am I doing this? I just saved it and it added some stuff to my imports. But why am I doing this? So I've created that hash. That hash is also going to be used on the short URL itself. I'm not defining a long URL because the long URL was already passed in with the request body. I'm just recycling what was passed in, and that's perfectly fine for this scenario, because if for some reason it was malformed or who knows, we'll end up somewhere else as far as an error goes. But we just added the short URL. Now what we want to do is we want to save it. So we want to save this struct that contains the ID, the long URL, and the short URL. So what we can say is we can say bucket.insert. The ID of this document, so this Couchbase document, is going to be url.id. We're going to provide it the URL struct and an expiration time of infinite here. And at that point, it will be saved. So let's check out the scenario now where the data that we returned inside of this nickel query at the start actually existed. So we're going to say else. We're going to say URL equals row. So now we're saying this URL is going to be whatever was returned as that first row in the result set. At which point now we can render it as a response. So we're going to say JSON.new encoder W, which would be our response writer inside of our function argument list, dot encode URL. And at this point we can save it. So let's go ahead and test this out, see if we've made any mistakes up until now, and then the next two endpoints are actually pretty easy. So going into our terminal here, I'm going to say go build, and then I'm going to run it. So it's going to be short URL. So it is running right now. To test it, because this is a put request, we can't just really go into our web browser. So instead what I'm doing is I'm actually going to use a tool called Postman. This is a Chrome extension. It's free. There are plenty of other tools that do the same job, but it will allow us to make any kind of request against our API. So we are doing a put request. So let's type it in HTTP localhost 12345 create. So if we go to our body now, we want to choose raw. We want to choose JSON. And let's go ahead and add in a value here, long URL. And let's say HTTPS www.thepolyglotdeveloper.com. And again, this isn't really a short URL, but imagine if you were trying to link to a URL from a forum board or something very long. It could potentially get long. So let's send it and see what happens. Send. We got our response down below. It contains an ID with a hash. It's rather short. It contains the long URL that we provided and a short URL that contains the hash appended to it. So if we go to our Couchbase database, we go to data buckets, and click on documents. That document does exist. So it does exist in Couchbase. It's saved successfully. It returned successfully. So let's go ahead and go back into our code now. We're going to finish up those other endpoints. Again, like I said, they're much easier than the one that we just did because we don't have to do all of these checks. So I'll go with the expand endpoint. So with the expand endpoint, we're actually going to provide a query parameter instead of a put body. This query parameter is going to be a short URL, and then we will plan to return the long URL. So let's go ahead and say var n1ql params. This is going to be a slice of interface again. We're going to say query equals bucket, not bucket, gocb dot new nickel query. And the statement will be select backtick bucket name dot star. So we're just going to return everything again. We can specify what we want to return if we really wanted to, but we're going to return everything. We're going to say from backtick. We're going to say plus bucket name plus where short URL equals $1. So instead of long URL, we're using short URL. For params, what we want to do is we want to say equals request.url.query. So this will get us our query params, not our nickel params, our query params. And then n1ql params, nickel params equals append n1ql params, and then params.get with a capital G short URL. So this is the name of the query parameter that we're looking for in particular. Now we can actually execute that query. We can say rows. We're not going to worry about the error in this case. Equals bucket dot execute. We could worry about the error, but we already saw how to worry about errors in the create endpoint. You can go ahead and do that if you wanted to. But we're going to say query, and then we're going to say nickel params. Now we can handle the result set, so we're going to say var row my URL rows.one. Remember, we're only expecting one. And this is going to be of type row. And then we can return whatever was that one row value. So we're going to say json.new encoder dot encode row and save. So I'm going to rerun this application. I'm going to show you a trick here to make it easier. So let me clear this. So we're going to say go build ampersand ampersand, and then we're going to say short URL. So it's going to build it and run it. So going back into Postman, I'm going to change my endpoint. So instead, let me copy this short URL. I copied it. I realized I copied the quotation mark as well. Let's go ahead and change this to a GET request, expand, short URL equals, and we can see the params here as well, equals that. Let's remove the quotation mark and hit send. And in theory, it should return the same thing. And it did. So it did work. So if I wanted to add another item here, let's go ahead and add another website. Send it. Let's go back to the first request. Let's run it again. It did return polyglot developer again, even though that we have two different records in our database. So we have one more step to go. We have the root endpoint. This is the home stretch. This is the short one. This is going to be very easy for us. So let's go to our root endpoint inside of our code. We're going to say params equals mux.vars request. So this is going to be a URL parameter, not a query parameter, not a body parameter here. A URL parameter. Var URL, my URL, bucket.get. So we're getting a document by its ID. Params ID, so ID matches what's inside of the curly brackets inside of our function main. And we're storing the result inside of URL. And then we're going to redirect to the long URL that's stored inside of URL. So we're going to say http.redirect w request URL.long URL. And this is going to be a 301 redirection. You could use 302. Choose whatever works best for you. I'm going to save it. I'm going to rerun it. This time around, what I'm going to do is I'm going to go to this document. I'm going to copy this short URL. It's copied to my clipboard. I'm going to open up a new tab. I'm going to navigate to it. And it did, in fact, navigate me to the destination long URL. So everything seems to have worked as planned here. So you just saw how to really configure Couchbase to allow for nickel queries. But more importantly here, you just saw how to build a very functional Golang application, this URL shortener application. It's RESTful, uses a NoSQL database. It does a lot, and it's a good introduction beginner tutorial for starting out with the Go programming language.